So you have a Spark SQL data frames and datasets guide. Okay. And this is a very lengthy documentation, and it's just read at least the basics. What is SQL? What is a data frame? And here we have an option of a data set. See here, a data set is a new experimental interface added in Spark 1.6 that tries to provide the benefit of RDD, okay, with the benefit of Spark SQL's optimized execution engine. So if you want to create a data set, okay, you can do that. So, and here are some of the examples, just go through them. So here is the creating data frame example. And if I scroll down, somewhere we have creating data sets, right? So if I have a sequence of 1, 2, 3, I can say to DS, and this will create a data set to me. Okay. The advantage of a data set is that you can directly perform the map operations and all on top of them. Okay. So a data set will allow you to practically write RDD based and as well as data frame based operations, right? So some of the examples are here. So I would request you to go through the Spark SQL documentation, which takes us to one of the use cases that we are having. Let me show you the data first. So we have a file called yahoo stocks.csv. So if you look at the structure of this file, the first column is the date, and these are all stock values of a company Yahoo. So we have the opening stock value, high value, low value, the closing stock value, the total volume of trade, and adjustments. So put it very simply, it's a structured data file. Now what if I want to create a data frame from this file? Now there are multiple ways to do this. I will first show you the hard way, then I will also show you the easy way. There is an easy way to do this, but first let me show you the hard way. And what is the hard way is, first I will read the data from this file and create an RDD. We know how to do that, right? Once I have an RDD, from the RDD I will create a data frame using the 2DF function, right? So what I will do, I will first read the data and create an RDD. And from the RDD, I will convert it into a data frame using the 2DF function. But just hold on. In this example, I will also do something different. I will use my own schema. So normally when you are creating a data frame, like what we have seen so far, Spark SQL automatically infers the schema. You don't have to type the schema. But this time, what I will do, I will ensure that, I will create my own schema, apply your schema. Now, if you look at Hive and all, it's very easy, right? So I'm quite sure that you're familiar with creating a table statement in Hive. You will say create table, then you say that name, string, age, integer. You will apply the schema while creating the table. But in Spark SQL, we cannot do that because we do not have a concept of table. We have a concept of a data frame. So what we do is that we use something called a case class. So if you refer the Scala documentation, you can see that there is something called case classes. Now, case classes are like regular classes with a few key differences, which we will go over. Case classes are good for modeling immutable data. Okay. So why are we using case classes? Okay. We use case classes to hold a static data, the data which cannot change. In our example, we are using case class to hold the schema for the data frame. Okay. And if you want to define a case class, you simply say case class and then give a class name. That is all you need to give. Okay. So the advantage here is that you don't have to instantiate it using the new keyword. Okay. Because They have an apply method which takes care of. So whenever you call a case class, automatically the object will be instantiated. You don't have to say that new and then the class name. Okay, it will automatically instantiate and create an object for you. So to put it very simply, case classes are like regular classes. They are used to hold the static information like the metadata. And in our example, we will be defining a case class to hold the metadata, the schema information for our data frame, right? First thing I'm verifying is that whether I have the data in Hadoop. I'll go here, look at my Hue interface, file browser. Let's say datasets. So I have my data available in a folder called datasets, and here is the data, Yahoo stocks.csv. So we know that the data is available in Hadoop. Okay, point number one. And what are the different steps we need? The first step is that I create an RDD. I will say that I want to create an RDD called Yahoo Stocks, okay, where I will do a sc.txt file and read the data. There is no rocket science in here. We are simply creating an RDD. And then if I will verify whether the RDD has been created. So if I do a Yahoo Stocks dot collect, well, we do have the RDD, but there is one problem in our data. Can you tell me what is the problem? Well, the data is read, there is no doubt about it, but there is one small problem in our data. We have this header. We don't need this, right? This guy. See this guy? We don't really need the header in the data, right? We can probably manually provide the column names, but in the data, I don't need the header. So there is an easy way to get rid of the header. Very, very easy actually. Remember the first operation, the first action, right? So what I'm doing, I will say Yahoo underscore stocks dot first, which will read the first element in the RDD, that's the header, and store it in a variable called a header. Okay, and then all you need to do is a filter. I will say I want to filter the data where underscore represents every element. I want every element not equal to header, which means practically I'm removing the header. And if I do a data dot collect, now we don't have the header. We have practically removed the header, right? So this is an easy way to remove the header if you want, right? So I just removed the header in this example. And now we have the entire data in an RDD called a data, okay? So I will say that, so this is how you define the case class, and it's very easy. You say case class and then a name for the case class, which is Yahoo stock price in this example, okay? And then within the case class, you give the complete schema for the data, like date, open, high, low, whatever schema you want. So defining a case class is very, very easy. You just give a name for the case class, and then within that, whatever you want to give. So here the schema, okay? I'm going to create the data frame now, and this is the command. So how am I creating the data frame? I will take the RDD, apply the map transformation, data.map. And I will say that I want to split each line using comma, because in the original RDD, if you take an element, they are all comma separated. And then again, I will use the map transformation. I will say that take every element and apply the Yahoo stock price case class. Okay, and then I'm saying that, okay, so I will say that for every X, what I want to do is that I want to apply the Yahoo stock price, that is my case class, and then you will access the individual elements within that. So this row 0, so remember the row objects are there in the data frame. So I am saying row 0, that means my first column. I am saying that the first column I am mapping with the first column in the RDD. Then again the second column I will trim it, convert to float, third column, fourth column, and I will say to DF, and I will hit enter. Oops. What is the problem? Why is it saying not found value row? Give me a moment. This is very interesting. Let me just check. Okay, data.map. Okay, I'll say split using comma. Again, map. Take every element, convert to stock price, and then I will say row 0, row 1 to float, row 2 to float, row 3 trim to float, row 4, row 5, row 6 trim to float to DF. This is very interesting. Let me check, okay, because ideally it should work. Are we not importing anything? Let's check here. It is throwing the error in here, you see. Where is the data? Data.collect. This part is fine. Closing parenthesis at the end where? Let me just check, okay. So for this, we have, for this there is an opening bracket and one more opening bracket. So that means we need two opening brackets, right? Row. We have two closing brackets, right? I'm not sure why it is. Very interesting. No, the closing brackets are fine. It is saying unable to find a row. That should not be the case. I have to figure out why this error is happening. Okay, because it used to work without any problem. Last time I tried, it definitely worked, for sure. Let me do one thing. I don't know whether any unclosed sessions are there. Let's relaunch it and see. Usually if you do this, it should convert and create a data frame without any problem. And that is the hard way actually of creating a data frame. Okay. There is an easy way to do this, but I wanted to demonstrate this for sure. Let's try this once more, see whether it is throwing an error or not. I will do the imports just to make sure that we are having everything. I imported the row, right? That's what. So I'm already doing that, right? So the row is imported. But last time also I did this. Not sure why. But this is not required normally. Let's see anyway what's going to happen. Header, and we will filter this. I have the case class. Define the case class. Wait. Probably some encoding issue. I have to figure out why it is not allowing me to create it. No, we don't need a capital R. The small r is good. So how many columns we have? So the number of columns we have is 2, 3, 4, 5, 6, 7, right? So the 0 to 6, and that's also correct, right? This part is also correct. I mean, my point is that there is no other way. You just map it with your case class and give the individual elements, and it should work without a problem. It says cannot error not found a value row. That's very unusual error, right? So not something very regular. Okay, since I have reached till this point, let me do one thing. I will try this. Let me bring up the VM, okay? I mean, this is a Hortonworks VM, and I think I will have the data here also. Just give me a moment, okay? $137, okay? 137. So this is the Hortonworks sandbox I'm using. Let's just try here, okay? Give me a moment. I will say that launch it. You have your home folder, and I just want to search for Yahoo. And so where is this Yahoo stocks.csv? Yeah, it's here only. And let's try this. 192.168.217.137. Okay. Let's start Spark Shell and also verify Spark Shell should come up. So the Spark Shell came up, which means Spark is working fine. Okay, so we have the shell, no problems with that. And I should do the same thing. Import org Apache Spark SQL, org Apache Spark SQL row. Okay. And we will do an sc.txt file of this. And if I do a Yahoo underscore stocks dot collect, we have the data. Okay, so it's working, this part. Case class. Here is the case class. There is some problem, serious problem. I might have to find it out. It's giving the same error, probably something that I'm missing. No, we don't need any functions actually. What if I want to read the CSV in another way, right? So what we are trying to do now was that we were trying to read a Yahoo stock CSV, and then we were, converting it into a data frame, right? But we were doing this in two steps. First, we created the RDD, then we were trying to apply the case class, and then we were doing that, right? Now, what if I don't want to do this? Is there an easy way to do this? And the answer is yes, there is an easy way. So let me do one thing. I'll connect it and I'll tell you. I think it's taking some time to connect. I'll change the settings. Appearance change. Okay. So I will bring up the shell again. Oh, sorry, I forgot. I don't have to bring up the shell. See, if you look at here, if you just go to Google, okay, and search for Spark SQL Databricks. This company called Databricks, right? So remember, Databricks is the company who sort of like the inventors of Databricks. They were responsible for creating the original Spark. So they have created a Spark CSV package. It's a third-party package, okay? And what this package will allow you to do is to read the CSV files. So one thing you can do is that you can read a CSV file, then create an RDD, then convert it into a data frame. So that might be the hard way. Now, if I go here, you have the CSV data source for Apache Spark 1. And all you need to do is, you don't have to start the shell like this. Okay. All you need to do is, there will be somewhere the command for this. Yeah. You have to start this Spark shell. Just copy this command. You have to start this Spark shell and then you say -- packages. Okay. Com Databricks Spark CSV 210150. So if I hit enter, what will happen is that it will download the Spark CSV package and add it into your shell. So you are starting the Spark shell only, but this time you are downloading and adding an external package to read the CSV files. And let me also show you how to read the CSV files using this package. So let it start. Started, right? And then if I look at here, we have a CSV file in Hadoop. Let me show you the CSV file. I go here. Datasets folder. We have a CSV file called, where is it? Starwars.csv. And we just want to read it. Okay. All we want is we want to read it. And if I open this is the structure of the file. It has the name of the Star Wars character, height, weight, eye color, hair color, JD, species, right? And if I want to read this guy, all I need to do is this. So first we'll see whether it works. I mean, it should work, but I'm just skeptical because the last one didn't work. Uh, it has to work 100%. Some silly mistake I'm making. Let me read it first and I'll give you the answer. Okay, it read. So what am I doing? I will say SQL context dot read dot format. So you have to use this. So you are saying that, hey, Spark SQL, I want to read the data, but I want to use this package. So you say com Databricks Spark CSV package, and then you can pass options. For example, header true. This means I want to read the first column as header and keep it as my header. Infer schema true. So I want this package to automatically infer the schema. Delimiter is comma and then the location. And now if I do a characters.df.show, we have the data. So this is the easiest way to read the CSV file, and usually this is what we do in the industry. So when we have a very large CSV file and probably with some complex schema, and if you want to read it, you use this third-party package and you will simply say SQL context read.format. We can even read we can even read the Yahoo stocks, I think. So what is the name of the file? Yahoo underscore stocks.csv. And I will just call it as another name. It should read ideally. Yes. And if I do a yahoo.show, here is the data. So, I mean, this is, I wanted to show you how to read it as RDD and convert it using a case class. And I will show you that, but usually we don't do that. Usually how we read CSV files is by like this. And even though initially, so in the initial days, what people used to do was that they used to define the case class and apply the schema. But this Databricks CSV package is so intelligent that it can identify almost any type of data and automatically infer the schema. And if your CSV file is too big, practically defining the schema may not be possible, right? So you may want the package to automatically apply the schema, and that is what we are doing here. Okay, so this is how you read the CSV file. Now, what if I want to read a XML file? So for different type of data, there is a different package that we have. Okay, and you may be wondering, how do you know about all these packages? Not me in general. This has to come with experience. There is no documentation or anything on this. Say for example, we were once working with Avro data. There is something called Avro. Okay, and there is an Avro package. We didn't know that. Actually, we searched here, Spark SQL, Databricks, Avro, and there is an Avro package available. Okay, so it's not like we can give you a set of instructions, and Avro, we have a package to read Avro, right? Let me show you XML data. XML is one thing which we can read a plain XML files. So there should be an XML file somewhere. There is employees.xml. So the important metadata that we have in the XML file is called the tags. And you have something called a root tag and a row tag. Normally, in regular XML files, we have something called a root tag and a row tag, right? And what is a root tag and a row tag? If I open this XML file, for example, so this is how the XML file looks like. It is some employee data. So this is your root tag. This employees is your root tag. And within that, this employee is your row tag. It's like nesting, not nexting. The outer level information is employees. That is your root tag. And inside that, you have multiple employees. So that's each employee record. That is the row tag. And if you want to read this guy, what you need to do is this. There is a package. You will say Spark shell packages Databricks XML. The command is already there. Okay, you will simply start the Spark shell using the Databricks XML package and let it start. And to read, this is how you read. You say SQL context dot read dot format, and then you say that you want to use this Databricks Spark XML, and the options are infer schema true. You provide the root tag and the row tag, right? The root tag is employees and the row tag is employee, and that's it. And once you have the data frame, obviously you can register it as a temporary table, and you can directly run data frame based queries.
I'm sure you enjoyed learning from this video. Please like the video, and if you have any doubts regarding this video, please comment us in the comment section, and don't forget to subscribe to our channel for more such informative videos. Do look out for other related videos in our playlist. For more information, visit our website now. Keep learning with Intellipaat.